Hi, good evening, everyone. It's already 5:37. I think we are going to kickstart the session. So my name is William. On behalf of the Academy Committee, a warm welcome to all of you on the second Academy sessions and the very first sessions we are doing it virtually. So first of all, I would like to thank all of you from wherever you are right now for taking the time and this wonderful opportunity to join us in this space, in the spirit of learning. If I can excuse myself to borrow 3 minutes from these sessions to explain to you a little bit of background about Academy, since some of you might be the first time joining. Now you might be wondering what is actually Aleph Academy. You might have heard of it from your colleagues. You might have seen it from Aleph Instagram posts. You might have also received the calendar invitations on your own. In case you are still questioning, I'm here to answer you. Next slide, please. Academy is actually a part of Aleph initiative to empower people through knowledge sharing session. It is a safe space for thinker, the curious one, and the fearless one to develop ourselves from mindset to skill set. Next slide, please. As we continuously grow this community, Academy is literally taking the roles of an institution within the organizations with the concept of borderless collaborations and open learning. By putting knowledge at the heart of this, with our strong belief that information is power, this is how the Aleph Academy was born. We invite the fearless one to venture beyond. In the future, we are hoping to bring you more with a lot more sessions that covers the topic or conversation that ranges from engineering, research, even to human-centered design, culture, or even groundbreaking ideas. So we are hoping that you are as excited as we are to learn, and please enjoy these sessions before I hand it over to Janaka, our speaker today.
Hey, thank you, William. Such a great introduction to what Academy is. I want to also thank nearly 70 of you who have joined. I'm really humbled that so many of you took your time away on a Friday evening to join us. So thank you guys for having me. Thank you everyone for having me. I do hope everyone is keeping safe and also sane, which is proving hard to do these days. So I also do love this new format. Last time we did this, it was physically in the studio, and that meant a lot of our colleagues from different regions couldn't join us. So now over Zoom, I guess a lot of people have joined, so I'm really, really happy. Being Zoom, I also want to ensure everyone that I won't prove it, but I'm actually wearing pants today. So just a few house rules before we get started. Emily is our host and DJ for the day. So she will have everyone on mute. So if you do have questions, I really encourage you to go on the Zoom chat and post it on the chat. William and Wu will be managing the chat, and they will be facilitating the discussion there. And William, feel free to join the discussion with me and bring any questions up to me if there's anything interesting that you think the whole group should hear about. So other than that, I hope everyone can grab some food and drink and enjoy the rest of the session. So I just want to talk a bit about myself for those who don't know me. I am an electrical engineer by training. A long time ago, I used to work in wireless comms, Bluetooth low energy radios, writing firmware for your routers, Wi-Fi routers at home, that kind of thing. But I found it way too hard to do. So at the same time is around the time when the Android OS came alive. For those who can remember, I think it was called the HTC G1. That was the first, I think one of the first public Android phones that was released. And because I was in this research area, I got a chance of a free device in my research lab. So I got a chance to play around with it. And that's when I got obsessed with writing apps. And I taught myself how to write apps. So then I moved on from the research world. I ran a a now defunct startup for a while. And after that folded, I joined Aleph, and I've been with Aleph for about 3 years. So in Aleph, I'm a user experience engineer. So what this means is I work really, really closely with a lot of designers and engineers and try to bridge this gap between engineering and design. So, and I think a lot of my design colleagues and engineering colleagues will attest to the fact that there is a huge, huge wall between design and engineering. And I feel there's a lot of space to improve how we collaborate with each other. So this has really, working with the design team for the last I think 1.5 years has given me a unique perspective of how we write software, and how we write code really interests me. So that's what I thought today I will share something about software design. Now this talk I did do before during the first session. So if you have already, if you were already there last time, it will be mostly the same, but do bear with me. I have a surprise at the end. So, so stay tuned for that. So I want to start with software architecture. A maybe you haven't heard of software design before. And a lot of the people, when they heard the topic of this talk, when they heard software design, William told me a lot of his colleagues asked whether it's actually a design talk. But this is still very much an engineering talk, but I think the design people will also be interested. So software design is not a very common word you hear in the engineering world. Software architecture is what we always hear about. So what is software architecture? So architecture itself is a word borrowed from the civil engineering community. So we have architects who come at the very beginning of a project. They draw up some plans and look at the requirements and make some high-level decisions. Essentially, they develop a blueprint and hand over to the builder, say, go and build it. So architecture, in a sense, is the blueprint, the early decisions that we make on a project. So unfortunately, software engineering is not like civil engineering. In civil engineering, the chances that requirements will change over the course of the project is very, very low. But in software engineering, things always change. I think most of you know that requirements always keep changing, the customer needs keep changing, and we need to keep adapting. So what that blueprint that we did at the beginning might not work out. Maybe 1 month down the road, 2 months down the road, it doesn't work out. So it kind of becomes like those decisions. Oh, I wished we did something differently. I wished we picked this language or another language. I wished we picked this platform or the other platform. And as time goes on, it gets even worse because some of these decisions are extremely hard to change. Imagine if you went on a project, chose React Native to develop a mobile application, and later on you realize it's not suiting your needs anymore, you need to change. You need to make a huge investment to change to maybe purely native approach. So if you're familiar with Airbnb first started with a React Native implementation because they wanted to get out there fast, but they very soon realized that it's not meeting their needs of performance and user experience, and they had to make a huge investment to get out of that and rebuild the app entirely using iOS and Android native. So there's a really good 5-part Medium article about that published on Airbnb. I suggest everyone should read it. So that's why I don't like to, that's why I want to move away from this word architecture, because architecture in a sense is, the word itself is very rigid, you know. So, but design, after working with designers, design is a good word. Design means that you can evolve things, you know. So, so for me, what software design means is continuously identifying what's important. So continuously identifying what's important to your team, what is important for your project, for your customer. And it can be things like those important things, whether a platform should be managed in a certain way, whether your team is managed in a certain way. We need to continuously identify what's important. So as an example, maybe at the beginning of a team, the team is very small. Maybe there are only 2-3 people and the trust level is very high between you. Maybe pull request reviews are not that important to you. But you want to focus on something else. Maybe get the project going quickly is more important to you. But as your team grows, you might think maybe you have 10 people now, 20 people now, and you can't have the same level of trust between everyone. So at this kind of time, pull requests become reviews become really important, because that's how you can encourage learning between the entire team. You can ensure your code quality, so things like that. So that's what I mean. You need to continuously identify what is important to you. So as an example, our team had this practice of good pull request culture we did have before all this work from home started. But we realized as we started working from home and collaboration is through Zoom or Google Chats and Hangouts, this pull request process was breaking down quite a lot. So what we got together, knowing that this is quite important to our team, so we came up with a slightly different way to do our pull requests. So we made sure that reviews happen on Zoom then and there. The author of the pull request and the reviewers join the call at the same time and review the have the author of the code walk the reviewers through and settle the feedback then and there. So we found for our team, this kind of works much better now. So keeping that continuous identification and making sure you're focused on what's important is very big part of software design. And the second part is a shared understanding, right? The entire team needs to have a shared understanding of what's important. So it doesn't really work if part of your team is thinking of something else and another part of your team is prioritizing something else. So even simple examples like, in the engineering community, there's a big thing about how do you indent your code, whether you use tabs or spaces. It's such a little thing whether they use 4 spaces or 2 spaces, but for some people this can be important because when you're reviewing code, there's a cognitive overhead when you see a different style of formatting, and everywhere you go the style is different and you can't really focus on the code because your mind is getting distracted by something else. So, and let's say another example, if for your team you decide an audit trail is really important to you, it doesn't work if everyone in the team doesn't have this shared understanding. So if the audit trail is really important to you, everyone in the team must come together and say, okay, we decide that this is important to us. So we have a very disciplined Jira system that we always move our tickets in a certain way. We always create our tickets in a certain way. And that is important to us. But it doesn't have to be important to a different team. Maybe their team doesn't care about audit trail. So your team needs to get together and decide what is important for you. So this is what software design really means to me. So it doesn't really need to be code related or a blueprint, or it could also be a process related or ways of working as well. So as an example, this is a funny example I used last time as well. So if you think about this, so we collaborate with designers to develop UI components that the delivery engineering team uses. So when the designers came up to us and showed us this design, so take a moment, everybody take a moment and think, what do you think this means? Is it something where you slide for progress, or is it something where you pick items from? So immediately when we saw this, obviously most of the engineering people, not just us, we all assume that this is a progress bar because it looks like a progress bar. But we do have a practice, another thing that we consider important for our team, that we have a shared understanding is about, that we want to know about what is the context behind this design, what is the context and what it's used for. So this allows, we found that this allows us to design our code and write our code better. So because of this, we have a practice where we always, when we see something on Zeppelin or Figma and we are tasked with developing this component, we always ask the designer. We have an interview system. We borrow the designer for 30 minutes and we interview him in a structured way and try to find out what is the use case behind this component, what is it used for, what is the context, maybe what is the real world usage scenario. So after interviewing this particular designer, we got to find out that this is actually an item picker. So it's not for discrete moving of the progress bar. It's indiscrete. So you can pick either 1, 2, 3, or 4. So it falls into a particular place all the time. So if you think about it, strictly speaking, if we had delivered this component to the downstream engineering team, both ways will work. Okay, I can argue that both ways can be used, but one way is significantly easier. If you look at this roughly pseudocode that's presented on the screen, one way is significantly easier for the downstream developer to start using this component. And what we've achieved here is that the person who's going to use our component is going to be much happier if we deliver the right thing for him. So I just want to reinforce what software design means to me is continuously identifying what's the important things and generating a shared understanding of what's important. So a lot of people don't realize that this is actually quite hard to achieve. So even within our team, we have a lot of contention and things start to break down. The team really needs to have a lot of discipline and unity to keep practicing this. And one would ask, well, if it's so hard and it makes you take a lot of time to deliver in this way, why do it? Why bother? So I want to take a step back and talk to you about how I started learning about all these topics. So if you see the person on the screen, I don't know, I hope many of you know who this is. This is Uncle Bob. Okay, Uncle Bob is the one who presented what clean coding is, what solid principles are. He's also one of the original authors of the Agile Manifesto. So when I found out about clean architecture, clean coding, solid principles, I was really obsessed with it. I watched all his YouTube videos and I studied all the material on his website and I started applying this. And this gave me a lot of personal gratification because the code is so beautiful, right? It's like art to me. When I write something, I want to frame it and put it on the wall. But I soon discovered that nobody else really cares about this because it does make me a bit slower to do all this in the correct way. And when the project manager or your scrum master is breathing down your neck saying, why are you taking so long? Why are you wasting time? I soon discovered that a lot of people don't really get why you should be doing this, because even though clean code always looks like it was written by someone who cares, and I think it's the right way to do things, it's the morally right thing to do, this argument never really wins, and nobody really cares. So then about 3 to 4 years ago, I found out about this guy. So this is Martin Fowler, also another original author of the Agile Manifesto. He is mostly famous for talking about refactoring, what dependency injection is. And if you're familiar with this guy, you will also know that most of the stuff I talked about earlier about important stuff, shared understanding, is what Martin Fowler spoke about. So I just copied it from him. So what he says is this moral argument actually doesn't work. So we need to make an economic argument. An economic argument is more compelling because obviously money matters, right? So let's take an example. Let's say I was building a piece of software and I got the requirements and I didn't pay attention to any of the important things, but I achieved what's the requirements and I delivered, and I was able to deliver this this software at $5, let's say $5. And my competitor Woo also built the same exact software. But while building this, he paid attention to some of these important things. He designed this software well, and he focused a bit on internal quality as well. So if you peek under the hood, it looks beautiful. But the customer can only see the external quality. So the internal quality the customer never sees. The external quality is what the customer sees. So at this point in time, both our external quality is the same, but Wu's costs are a bit higher because he had to focus a bit on internal quality, and he is able to sell this software at $10. Let's say $10. The cost is double. So if you think about it, which one will the user buy? Obviously, the customer is going to buy the cheaper one, right? Because as far as the customer is concerned at this point, it all looks the same, right? The customer can't see what is beneath the surface, right? So but software is never, at least modern day software is never about building something and delivering and forgetting about it, right? Modern day software engineering is about continuously delivering value to the customer. So customers always want more features and improvements, better user experience. So you need to keep updating your application or delivering new features if you want to be successful. So what's going to happen to me as these new requirements are coming, because I haven't paid attention to internal quality? It's going to be, I was faster at the beginning, but it's going to get harder and harder for me to deliver new features, because every time I open the project, I don't know what's going to go wrong. I don't know where the bugs are. It's going to be really hard for me to improve. So there comes a time that my fast output is going to flatten out, right? But if you consider Wu, because he's a smart guy and he has organized his project well, he has focused on his internal quality. At the beginning, he was a bit slower, but he is able to continuously provide value faster and faster. As time goes on, he's able to deliver new features faster and faster. So at some point, he's going to overtake me. And at some point, I'm going to get stuck, and he's going to overtake me and be able to deliver better features. So if you remember, I told you about my failed startup. This is one of the reasons, because at that time I didn't know much about this, and all we thought about was getting out there as fast as possible. We didn't focus on what is important, what kind of quality, internal quality is important. And at some point it became harder and harder for me to deliver new features. And there were other competitors out there who were just getting better and better, and I couldn't compete with them anymore. So so that time frame where where Wu is going to catch up with me actually comes much faster than people realize. So I have personally experienced where we think we'll take some shortcuts and deliver this thing in 2 weeks because we're just focused on the short-term goals. We are able to reach this point, but when we go beyond this point, it becomes harder and harder. And generally this works out to be, at least in my experience, it works out to be about a month, 4 to 6 weeks. So I want to focus on, So I hope you can appreciate how this kind of failure can have a very real impact on. It happened to me in my business, and it can happen to people who don't really focus on the important things. So like I said, every team, every project should decide for themselves what is important for them, and you can't apply these things as a general rule across all teams in your organization. But for this talk, I focused on, for the purpose of this talk, I focused on three things: that with experience and considering the nature of our business and what kind of projects we do, we can decide some common baselines. So if I'm going to say what is important to us: cycle time and mean time to recovery. So cycle time means the time someone has an idea in his head. How long does it take for us to put this into production and deliver into the real world? So the shorter cycle time is a competitive advantage to us. Okay. Mean time to recovery means how long does it take for you, on average, for you to, when a defect is reported, how long does it take for you to fix it? The average time it takes for you to fix it, right? What else is important to us? Borderless is important to us. As an organization, we are spread across a couple of regions, a couple of countries. So to be able to collaborate easily with each other, to help each other out, is an important competitive advantage. So if I'm having trouble in Singapore, if I can lean on someone in Malaysia or Indonesia, that is a significant competitive advantage. So obviously, quality of our work and our reputation is really important to us as well. So let's walk through an example, a real world example that I had to do. So we were tasked with building the just the login part of an app. So it was very simple. There's a splash screen, there's a login screen, and you when you log in successfully, you go to the dashboard. Simple as that, right? So what do we do when we see this design? Don't ask many questions. We are coders, so we love to code. Directly open your computer, you start coding. So what did we end up with? Because we didn't do any planning or didn't decide what kind of things are important to this and didn't anticipate anything, everything went in one single file, and this file kept growing and growing as things kept getting added, and there were like 1,500 plus lines in this, and there were 93 functions, 107 properties in a single file. In a single class, there were 107 properties. So you can imagine how difficult it is. How difficult it is to, if you think about what is important, how difficult it is to consider cycle time, consider mean time for recovery. So with this kind of huge file, anytime a new feature needs to be delivered on this file, it's going to take a long time because it's very hard to navigate yourself in this file. Or if you have to find a bug, it's going to be really, really hard. So at this point, I'm getting really nervous and I'm really in deep trouble. So it's time to call a friend. So when I call a friend and he looks at this code base and he sees this mess and he's like, well, I can't help you out with this because I don't know where things are, right? So it's very difficult for someone who has zero context to come into a source file like this and try to understand and help you. So we failed on cycle time, mean time to recovery. We failed on our borderless goal. And obviously, when it comes to quality of work, I hope nobody ever saw this. So what we want to do is go back in time and decide we want to try this again. So when we get this kind of requirement, we want to understand that it's a fluid situation. Perhaps the backend is not ready. perhaps the design team have not yet finalized their designs. But I also don't want to say at the same time, look, I can't work with these guys are not ready, those guys are not ready, so I can't work. That is also not an outcome we want. The way we want to proceed is design our code in a way that can protect ourselves from backend changes. Design our code in a way that protect ourselves from design changes. So we want to fairly segregate these things, that when some changes happen elsewhere in the app, that things don't break in other places of the app. So we want to take this into consideration and say, look, I can't deliver this really, really fast, but if you give me some time to organize this properly, we will be much faster when those new features come in. So the way we want to do this is split this app into a couple of parts. We want to segregate all the service connections, your database connections, your responses, caching stuff, all into something called data, kind of a data package or data folder. And you want to separate all your UI things, all your screen designs, your custom widgets into a separate folder or separate package. So we can fairly abstract these things out and make sure that whatever happens on the backend things, if they change, if the UI doesn't get affected, and vice versa. If the UI changes, we don't need to change anything in the backend service connection things. So, but you also soon realize some features are a bit more complex. Maybe when the user logs in, we need to check his age and maybe call a different type of service based on the age. Or maybe we have a free version or a paid version. And based on some configurations we get, we want to show different types of features. So we also introduce what we call a domain layer. So all the stuff that we talked about, this application specific logic, we put in the domain layer. So notice the difference. Let's take an example of the user itself. Notice the difference how a database stores a user is different to how a user is maybe represented on the screen. And it's also different to how we model a user in the real world. So a user in your data layer is optimized, user response is optimized to be delivered through the network. And it will have headers and all sorts of other metadata that is only relevant to the communication between the network. And if you think about how the user is presented to the screen, it's optimized for user experience, because that's what this user model is concerned about. And if you think about the user in the domain, that is more concerned about modeling the user in the real world, how a user would look like in the real world. So we don't want to, we want to have a clear segregation between these three things. So that is where the domain model comes in. And as your app matures, you will find that this domain starts becoming the meat of your app. And if you have done things right, you should be able to entirely peel away your data layer. You should be able to put another implementation of the data layer, and we don't have to touch the domain or UI. And maybe the design team has a new idea of how to represent the screen. They want to introduce a new type of loading experience or something. And we want to be able to do this without touching any of the domain or data layers. This is the whole concept here. So if this kind of thing is familiar to you already, this is what we call clean architecture and solid principles. So I did have a small article about it in GitHub. So I'm working on publishing a Medium article. So do look forward to that. So we come back to what is important to us. So given that, let's think about cycle time and mean time to recovery again. So given that your data layer is fairly abstracted, if the backend people say, look, our backend services are aging too much, it's not fast, we want to move to this new fancy thing called GraphQL, which is really awesome. we as a front-end team is able to say, sure, no problem, you guys can change, and we just need to do some changes in our data layer, but nothing in the rest of the app that needs to change. And we are able to deliver these things faster. So this idea can go to production much, much faster. And if you think about mean time to recovery, if you figure out that your app is crashing due to a service call, due to a service call, you can really pinpoint the bug to say that, okay, this is happening in the data layer because maybe your response model mapping is not correct or something like that, right? And also, if you come back to borderless, considering that we have a set pattern of how we develop, how we organize our source code, our approach to delivering software comes out of a similar template, anyone can go into a different source code and quickly understand, because all of the projects are organized in a certain way, quickly understand how you can help each other. And if you think about quality of work and reputation, I think other people will automatically tell you what your quality of your app is. So what we couldn't do last time is to show you actually how this works in real time. So what I wanted to do today, what we didn't do last time, is actually show in code how we can implement an entirely new backend system to an existing app, how we can implement an entirely new UI feature into an existing app without breaking anything else. So to do this, I want to welcome Praveen to the stage.
Hey.
So,
Hi,
hi, Praveen.
Hi.
Praveen will share his screen, and anyone who wants. So what we're going to do is I'm going to show you some Android source code. Praveen is our resident iOS expert, so he's going to show some iOS source code. And you can, if you're in the audience, you can subscribe to either of the screens you want. So there's a little button at the top. When you go under sharing settings, you can drop down and you can pick which screen you want to see. So if you have trouble figuring this out, I think Wu, if you ping Wu on the chat, he will help you out.
Yeah, okay.
Yeah. So, oh, I forgot to ask so far, any questions, Wu?
Nope.
Perhaps
Yes,
everyone's,
feel free to drop question. I'll be asking on behalf of you guys.
Perhaps everyone's fallen asleep. So let's proceed. So what we did, Praveen and I, we spent maybe 2 weekends. We built a journaling app, right? So if you're from Aleph, you're already familiar with what journaling is. It's kind of an essential part of our culture, right? What we do is daily we write a small note about what we set out to do, what we accomplished that day, and did we face any problems that day, and generally what we are thankful for that day. And we blast it out to everyone, so that this helps us keep hyper connected with everyone, especially now since everyone's working from home. We don't get to see each other that often, or not at all rather. So this is a kind of way that we stay hyper connected with each other. But there is a really, really big problem with this. We currently do this via email, and it's not a great experience to write this via email. And it's even a worse experience if you're reading this via email. If you think about maybe Arvind, he probably gets like 400 or 500 daily journals every day. Imagine his inbox. It's just getting polluted. So what we did is we built a small app. I'm going to switch my screen to my emulator. So, okay. So it's a very simple app. So is everyone, I hope everyone can see Wu's screen, sorry, Praveen's screen. If people are having trouble figuring out how to view Praveen's screen, just ping Wu and he'll help you out. Okay, so This app is quite simple. Good? Ooh.
Yeah.
Okay, this app is quite simple. All your journals come up on your home screen. It's like a feed. And as you can see, I've sent my journal yesterday and it says I spent the whole day doing nothing else but preparing for this talk. So maybe I can, that's one feature, and the next feature is obviously creating journals. So I want to maybe send a journal for today. I'm going to give it a title. Okay. Okay. Right?
Yeah.
Yep. Yeah. So I write my journal and it gets published. So let's quickly look at the source code, how it's organized. And you can, like I said earlier, you can either look at Praveen's screen or my screen. Both are the same, except that he's doing an iOS app. I hope it looks the same, Praveen.
Yeah, absolutely same.
Okay. So if you open this source code, you can see these are the things that we talked about earlier. And there is a data package, there's a domain package, there's a UI package. The UI is obviously most concerned about how the UI is organized. The data is concerned about how the service connections are made, and the domain is organized, is concerned with how your application, what are the use cases of this application. So I don't really want to go very much in detail, about what we use to build this app, but it uses a lot of this clean architecture modeling and reactive programming, because functional reactive programming is a much better way to model modern day applications, and it's all tied together with dependency injection. So we are going to talk about these things in detail in future sessions. But for now, just focus on the structure of this app and how it looks similar in Praveen's screen. If you want to switch screens, also possible. You can see that it looks almost identical. And even if you go into these folders, they look almost identical. So the idea is that I can look into, and my expertise is probably not in iOS. Praveen's expertise is probably not in Android. But we can look at each other's source code and understand what we are doing is almost the same, and other people can collaborate easily. Because ultimately, even though it's an iOS app, Android app, you're building the same application. So our goal is to make our source code look as similar as possible. So let me see. So this app has a big problem, right? So Praveen and I know nothing about backend services. We really didn't know what to do, but we also didn't want to wait and not do anything. We just built the app without any backend integration. So if you see, if I kill this app, all these things are stored in memory. Yeah. All my journals are gone, right? That's no good. So shall we fix this, Praveen?
Yeah, sure. Janaka, before we start the coding, I just want to tell something.
Yes, go ahead.
Yeah, for the reactive programming, for the iOS guys, I use the reactive Swift and the reactive Cocoa. And for the dependency injection, we use the Swinject. So I thought of using the reactive Swift first, but later I think like maybe reactive Swift is more complex. So that's why we choose the reactive Cocoa and the Swift together to do the reactive programming, and the Swinject for the dependency injection. So yeah, Janaka. So I use the Cocoa pods to integrate this as a dependencies. So you guys can see my pod file here. So reactive Swift, reactive Cocoa, and the Swinject.
Yeah, that's a good point. dependency injection itself is very, very common on Java-based systems. It's very common on Android. But I have to say, I don't really see it. I don't think it's very common in iOS project. Is that right, Praveen?
Yeah, yeah.
So even if you see all the libraries out there, there are a couple of libraries for Java-based languages, but not much for Swift-based languages or Swift-based solutions.
There's a question about dependency injection.
Yeah.
Someone is asking whether you guys have checked out Cleanse for iOS.
Yeah, I use the clients for the iOS, but actually like Swinject has the more community. That's the reason I have chosen it. But clients also a good one. You can choose whatever the dependency injection library you want, but the idea is just to not to depend on the hard coding the things inside the classes, so that you can easily react to the changes.
That's a great point. I mean, it really doesn't matter what library, whether you use RX or whether you use Reactive Swift, whether you use Dagger, whether you use Coin. It really doesn't matter which tool you use. You can write bad code with any tool. You can also write good code with any tool. So it's just a matter of picking the right thing and organizing your source code the way you want. So, okay, let's proceed.
Hey, Janaka, before you start, someone saw that your battery level is pretty low. You might want to check.
That's a good one.
I think Eric pointed out.
Done. Thank you. So since we don't know much about the backend, Praveen and I decided let's integrate Firebase. That is the easiest thing to do. So we don't want to focus much about the implementation, but let's just see. I just want to show that what we do here doesn't touch any of these, anything in the domain, anything in the UI. And it also doesn't touch my existing implementation, because we are going to write a totally different implementation and use dependency injection to inject the correct implementation. So you can see this is a pretty rudimentary thing. Whatever journal we created, we are just storing it in memory, which is why it gets deleted when we kill the app. Let's go, Praveen.
Yeah, sure. Okay.
So Emily can play some heavy metal if you want.
So guys, feel free to drop a question. I will ask them. The best time to ask them is when they are coding.
Actually, that is the worst time to ask questions, because I won't be able to concentrate. I'm just joking. Please ask any questions you want. We will facilitate the discussion. So, okay, this is asking me to implement some functions.
Yeah, so Chihong made a comment about the benefit of using clean architecture. Use clean architecture, probably you get a good test coverage. Yeah, I think that's one of the benefits, where when you use clean architecture, you get better testability.
Yeah, that's absolutely right. So one of the good side effects of clean architecture is it makes your app extremely test friendly. It makes testing so much easier. So first problem. I have a problem with imports.
And I also would like to encourage iOS developer to subscribe to Janaka screen just to take a look like how things are done in Android, because what this clean architecture also promises the code similarity. So, I mean, if you take a look, it's pretty similar. I mean, what you saw in what Praveen's coding.
Yeah, so you guys should switch screens and compare the code that we do. So I'm going to first implement get journals. And this is way more stressful than I thought. And Nischal is also watching, even more stressful now. So I'm just going to log this exception.
The database instance for the file store here by removing the local memory. That's what we are using previously. So now I can fetch the data from the file store.
I mean, let's use a new collection name, just users all lowercase, just journals all lowercase. Get.
We're going to implement first the error scenario, right, Janaka?
Yep. So Kotlin, luckily, is quite an awesome language. It has a lot of helpers for us. So what we get from the Firebase data store, we need to convert it into whatever our object model is here. So let's just create one more thing. We have an ID. We have a title. We have a paragraph. Maybe Emily should play some light music to liven up the mood.
Developers, one of the challenges is to work closely with your counterpart. By that I mean, as an Android developer, you have to work closely with iOS developer, and most of the time you have to build the same thing. And I find that when you code in the same language, with the help of clean architecture and clean design, it helps a lot on the collaboration. Because I think very often the product requirement is that Android and iOS most of the time should behave the same. And to ensure that, one way is to to really code in the same language.
Yeah, that's absolutely right. One of the challenges that we face even in our UX library is that we need to achieve the same thing across iOS and Android. So we spend a lot of time making sure our approaches, our API design is almost identical on both platforms. So Praveen, how are we doing? Get journals ready?
Almost, Janaka.
Okay. So I'm going to move on to create as well. I'm going to cheat a bit here. Any of this. So it's really not important how, at least at this time, how these models are organized. But it is important to note that this model is not the same as this model is not the same as what you see here. As I said, the reason is we want to keep these things separate so that if something changes, it doesn't affect across the layers.
Janaka seems done. Get journals.
Let's quickly move on to create as well. So I'm writing a bit of not so nice code. Maybe don't look at this part. So Firebase organizes data in just dictionaries. In iOS, you call them dictionaries, I guess. And in the Java world, you call them hash maps. Okay.
We have a question here.
Yeah.
So Rejo is asking whether clean architecture is also for something like for features that has a lot of like publish and subscription mechanism, distributed caching. Yeah. And
I'm not sure whether I understand the question correctly. Is the question about whether it's suitable for kind of WebSocket type of application or live?
Yeah, probably. Maybe Rejo, you can clarify. Probably, I assume so, because he also asked whether what's the best language to achieve such architecture. I mean, clean architecture. And he also asked about whether Golang is a language that is also capable to implement.
Yeah, I think most modern languages support concurrency and reactive programming quite well. Swift, obviously on native mobile native platforms, you're limited to what's offered from the platform. So if it's iOS, you're pretty much stuck with Swift. If it's Android, you're pretty much stuck with Java or Kotlin. But if you're developing middleware for a server or something, Golang is a great choice. There's Scala and things like that as well that are quite suited for reactive side programming. Okay, Praveen, how are we doing?
Almost done with Janaka, just implementing. Yeah.
So do you want to take one more question? I think it's Janaka, can you take one more question now?
Yeah, go ahead. Keep talking. Try and disturb me as much as possible.
Okay, it's from Rohit. It's asking, should we use file store as dependency in the repo, or instead get data from file store as generic?
Yeah. So maybe this line of code is not ideal. You probably want to inject this as well so that your repository is also protected from the actual network layer, what is happening. That's a great question. But for this purpose, to do this very quickly, I encapsulated Firebase within this implementation. So shall we update our injection model, Praveen?
Yeah, sure.
So I think if you look at Praveen's screen or my screen, you will see something like this. Our previous repository implementation is what is getting injected, our old one. And what we want to do is replace this with our new one. Comment this out. When you use the collection as journals, right?
Yeah, collection as the journals, correct. All small.
So Have you run?
Yeah, I will run. I think so. I'm not got the data. Is this a new collection, right?
Empty collection, yes.
Yeah. Okay.
So, okay, hopefully this compiles, there are no problems. Praveen, you can go ahead and show maybe you create and hopefully it appears on your screen.
Okay. Yes, what I'm doing is I'm going to create a new journal now. So similar to the previous what I did.
Okay, in the meantime, let's take more questions. So, Puka, you're asking about event-driven development. Not sure what you want to know about that. Question from Martin. Is it better to package by layer or by feature? Layer in the sense data.
Yeah, I got that. That's actually an excellent question. This might come down to personal taste. And it's actually, there's a good argument to package by feature first, then layer second, so that your application source code immediately tells you what this app is all about. But I find that this kind of becomes hard to achieve in complex application because a lot of these features may share things, and then it becomes a bit harder to, okay, where do I put the common stuff? That can become hard. But I think both approaches, well, it really depends on the use case. So, so right now, if you see Martin, if you're watching my screen, or I would expand this interactor, and maybe all your feature related use cases will go in here, and you can further package them into logically related use cases. Maybe if this app goes into something else, we might have maybe journals package, and maybe subscriptions, things like that in their own packaging here. And then if you go to UI is still organized by the screens in your app. And the data is organized by the service related things in your app. But you can flip this model the other way around as well. It really depends on how you want to organize your code. Okay, I think it works, right, Praveen? Good.
Yeah, you got my journal?
Yes. So as you can see, I can kill this app, come back to it. Things are hopefully still working. Yes, I can maybe write a new journal. Right. Yep. So what I want to show is, what I want to really drive home is like we totally swapped in a new back-end code without touching any of these code. Right? I only changed the dependency injection here and implemented a new file here, but I have not touched any of the domain code, any of the UI code. I haven't touched any of this, and it's also visible if in your diff. Right? Only 3 files have changed, but we have totally swapped in a new backend. And what this means is none of these areas require retesting or regression, and your existing test cases should run without any problem. Even when you come here, if you notice our method signatures for our old implementation, our method signatures for our new implementation have not really changed. So you can still use your old test cases for your new implementation as well. So this is, I hope you can appreciate how like the value of organizing your code this way. So this is an example of how we totally took a new data implementation and didn't touch any of the other parts of the code. So let's see what other problems this app has.
I see, Janaka, well, I just sent a journal, but because we haven't not able to refresh on the home page, it's not displaying. How about implementing the pull to refresh there?
Okay, awesome. So that's the other problem. So I guess people are publishing journals, but unless I kill my app, come back to it, I don't get refresh. Right. So this is a kind of, perhaps I have a gut feeling that this only touches the UI. So let's go and implement that. Praveen, ready?
Yeah, ready, Janaka. Let's go.
I'm only going to touch these classes. Okay, I'm going to commit this so that it the change becomes clear. So let's. I'm just going to wrap this in a swipe, refresh layout.
Also, non-technical question welcome as well. You can ask about the app, you know.
For the pull to refresh in the iOS, what I'm doing is I'm just implementing the UI refresh control and just adding it to the collection view. So,
If you're an Android developer, this should look familiar to you. If you're not, it's really not important. What I want to drive home is that we are only touching certain parts of the code without affecting any place else. So inputs. This one. And we have a signal from our view model to tell it to refresh the journals. Let's just post that signal. And when it's refreshing, I want to make sure after it's refreshed, set it back to false, both in the success case and in the error case. All good, Praveen?
yeah, Janaka, almost there. Give me a minute.
So Janaka, do you have plan to open source this project, and are you looking for contributors?
I don't know about open sourcing, but I am dead serious about taking this app and making it a real product. So yes, contributions are welcome. People can ping me and find out how to contribute. Let's see how it would be awesome if we can open source, but maybe that's a conversation maybe further down the road. But really, I would love some contributions. How are you doing, Praveen?
Yeah, Janaka. Yeah, let me compile this. Okay.
So while this is building, Praveen,
Yeah, Janaka, awesome, it works. Shall we test?
okay, mine is still building.
Let me publish a new journal. Okay, so once we build, I will publish.
So yeah, so mine is building and working. I can pull to refresh. I hope everyone can see that. Maybe Praveen, maybe you publish something. Let's see whether it appears here.
Yeah, Janaka, done. Just publish a journal.
Okay, let's see if I refresh to get Praveen's data. Okay, awesome. Okay. I also want to fix one more thing, Praveen.
Okay.
Okay. This loads. I don't like this empty screen. You know, before it loads,
Okay, what do you want to propose then?
You know, we learned from our good friend Tien that he loves these skeletal loading animations.
Okay.
Do one of those?
Yeah, let's try.
Let's try. Last thing, I promise. Okay. So for this, I'm going to cheat a bit. I saved the layout somewhere.
Me also, Janaka.
Okay. So it turns out I saved the wrong file, so I'll have to do it all by myself. What shall we do? I have to look this up. Billy, let's have some music if there are no questions.
No more questions so far at the moment.
Seeing my screen, they wonder why I am creating all these numeral changes for the displaying schema instead of just adding another cell type of a collection cell type.
Hmm.
I will tell you guys later. Just let me show the schema first. I will explain you the changes later.
Just put it here. Any ideas? Move.
Well, what?
Any ideas how to quickly do this?
That's about it, right? I mean,
I hope this works out.
enough to show.
I hope this works.
Yeah, awesome. Working for me, Janaka. How you doing?
Not great.
What happened?
Okay. So since we are kind of short for time, if Praveen is done, maybe people can see his screen and see the shimmer layout, how it works. When you pull to refresh, I think it's shimmering for the first time. When you close, it's shimmering, and when you pull to refresh, it doesn't shimmer, correct?
Yeah, Janaka. Before I fix this issue, I will quickly explain one thing.
Yeah, go ahead.
I promise you guys to explain why I created these models inside the UI, right? So okay, when Janaka asked, like when we try to show the schema, first I thought like, okay, just create one more collection with cell here. So which actually display the schemas. So, but later I understand that in our early journals, the important thing is send the gratitude. So as of now, it's all the text cells. It's okay to do these things. So if I have an image to show and edit, display all these things, it's going to be complex. Maybe I have to create one more collection with cell type, and then it might be very complex for me to do inside this, doing if else, whether it is schema, all these things. So what I created is, we created a model called home item. So whatever I'm displaying in the home screen is just implement this home item protocol. So whatever it comes, maybe image, videos, whatever I want to display here, I just create another item here, like what I created, like a schema item. I will extend it from the home item so that I no need to do any changes in the view model here. If you see, I just created a shimmer item. This I created 6 just to full all the screen with the shimmering to just to see while we seeing it looks beautiful. That's the only reason I created a 6 item. And then instead of your journals, I just send these shimmer items to the value to a signal. So then when you pull, if the Firebase is fetching the data, you can see that shimmer is there. So that's the reason I choose to create this home item. Yeah.
Okay, great. Okay, so what I want to drive home again is what you've seen from Praveen and what you've seen from my implementation, even though was not quite as awesome as Praveen, I couldn't finish my job, is that we didn't touch in this process, even when we are changing the UI, we've totally included a new feature, we have shimmer layout, we have pull to refresh, but fundamentally, nothing in the app changed. That means the domain layer shouldn't change. The data layer shouldn't change. And if you look at the diff, also it's you see only in the UI package and the layout files are changing. So again, what this means is all your test cases for domain, all your test cases for data are still intact, and you don't have to run any regression for these places. You only have to worry about the stuff you changed in your UI layer. And if you wanted to totally, like we did in the data case, if you wanted to drive this as an independent view model, you could have created maybe a new home view model just to test out a new UI implementation. It's also quite possible. So I want to, so I hope you can appreciate that the clean architecture is a bit slow to begin with, but when you get into complex projects, I feel it becomes much easier to introduce changes. And I have been on both sides of this case where we've organized projects very well, structured them into these packages, modeled the domain area quite well. And I feel if you have modeled your domain very well, it really doesn't matter what your UI is. It really doesn't matter what your backend is. You can change and swap this implementation. But if you haven't taken the effort to do this, you will run into trouble quite fast. So I'm sure many of you have experienced as projects mature and you've been contributing to source code long, if you haven't maintained it properly, it becomes increasingly difficult to keep up with requirements, keep up with maybe new design features, keep up with new backend changes. It becomes harder and harder. So this is really, really what I wanted to drive home today. So, so to recap, I hope everyone starts thinking about what is important to your team, and I hope everyone in your team gets together and comes to a shared understanding of what these important things are. So in this particular case, for Praveen and I, was to structure this project to be able to, peel off the data layer and totally implement a new backend integration in a matter of minutes for us to be able to do this in this presentation. And I think it's quite valuable. So I guess that's about it from me. So I really want to say thank you for superstar iOS expert Praveen for really helping me out on the weekends to come up with this idea and to present, and to do live coding is no easy task. Especially with Nishal is watching, Aman is watching, so it's quite nerve-wracking. Luckily, I've had a beer already, so I'm good. So I'm Emily. DJ, you can play some music. I'm around for 5 to 10 minutes. If anyone wants to ask questions, you can ping Boo and you can share with the group. Anyone wants to share anything. Other than that, thank you everyone for joining. We will generally this event every last Friday of the month. So next event, Poon has promised us, or I'm putting him on the spot. He's going to promise us that he is going to do a design-related talk. So I'm sure it's going to be interesting. Poon, I hope you heard that. I hope he's here. And also every second week of the month, we do bite-sized sessions. So just our 30-minute sharing, very live coding session. Everyone can learn something, how we solved a particular problem, or some experience in the previous week. That kind of short lunchtime session happens every second week. So yeah, that's it from me. If anybody wants to say anything or has any questions, you can ping on the chat. Thank you very much.